All right, good afternoon. Not here today, but you're still here and you're still going to get a joke of the day to start off. Why was the baby ant so confused? Because all his uncles were ants. Yes, yes, yes. Another joke of the day. You weren't getting away with a joke without a joke of the day today. So what we're going to cover here, you've already done your ACT warm-up. Hopefully got those all taken care of. Your quiz is back, so I'll give you your quiz backs next class. Just an FYI, we'll get those back on Wednesday. We're going to do a little synthetic lesson here, and then some long division, and then a work time. So you should have a handout. Make sure you have that out, and you're following along with me as we go here. Again, quiz is back next class period. So first problem up here. Oh, and we're just zooming out. There we go. Oh boy, here we go. All right, so if we want to use direct substitution, we've done these problems already this chapter. Basically what we do is we just take -4 and plug it in. So if I'm going to do f of x equals 5 times -4 cubed minus -4 squared plus 13 times -4 plus 29. We plug it in and we go ahead and solve here. -4 cubed is -64. -4 squared is 16. 13 times -4 is -52, and then plus 29, that's a 29 right there, 29. Again, make sure you're following along, writing this down as I write down. -64 times 5 then is -320, minus 16 minus 52 plus 29 right here. And then we go ahead and add all of those numbers together, and we should get, I believe, a -359. And we've done this before and plug those in. The problem is, what happens when we get like 5x to the 9th plus 3x to the 7th? So we get those really, really big exponents. Well, then we get really, really big numbers. Sometimes we don't know if we should keep it negative or should keep it positive. So instead, what we came up with was this thing called synthetic substitution. So now we're going to use this synthetic substitution. You'll notice here it's the same problem. And how you set up synthetic substitution is you put the number that you want x to be into a little box right here. And then what we'll do after we have that box is we'll write next to it the coefficients for each of our terms. So 5, -1, 13, and 29. Again, these are the coefficients of each of the terms right there. And then I'll leave some space, leave a couple lines, and then I'll draw a little line with a box at the end. And this is going to be called synthetic substitution. There's a process. It's just steps that we repeat right here. So the first step is to bring the first number down. That's not in the box, so that'd be 5. And then I'm going to take that 5 and I'm going to multiply it times -4, what's in the box. And I'm going to write that number, which is -20, diagonal. Okay, so we take the bottom number times what's in the box and then write it in the next spot diagonally. And then what we do is we add straight down. Add straight down. -1 plus -20 is -21. So we add straight down. And then we repeat the process. We take -21 and multiply it by -4. -21 times -4 is +84, and we write that in the diagonal place. And we're going to repeat this process. We're going to add straight down, and we get 97. And we'll repeat the process again. 97 times what's in the box, -4. 97 times -4 is -388. And again, we'll add straight down. 29 plus -388 is -359. Well, what do you notice ends up being in this box right here? It's this answer. So synthetic substitution allows us to just set up this kind of way to solve the problem, and then our answer is in the box at the end. Okay? So this is synthetic substitution. Put what's in the box, put the number that x is in the box. So let's just do a couple more here. We've got this example, 4x squared minus 10x minus 21 when x equals 5. This one wouldn't be too bad. We'd just plug 5 in, square it, and so forth. Let's go ahead and do it though. So we'll set this up synthetic. 5 in the box, 4, -10, and -21. And then we'll draw it here. with a box. And let's just go ahead. Bring the first one down. 4 goes down. Take 4 times 5, you get 20. Goes in the next spot. Add straight down. Negative 10 plus 20 is 10. Multiply by 5. 10 times 5 is 50. And then add straight down and you get 29. And 29 is your answer if you plugged in 5. And you could go ahead and do that. 5 squared is 25. 25 times 4 is 100. Minus 10 times 5, which is 50. Minus 21 would get 50 minus 21, which is 29. And we get the same answer. Okay, this is synthetic substitution. I'm just going to do some examples for you here today. Here's another problem. F of x equals 5x to the 4th plus 2x cubed minus 20x minus 6. Now you'll notice on all these problems we've had the highest exponent, like the previous example was x squared, and then it was x to the 1st, and then it was no x's. So they go in standard form. You'll notice this one's also in standard form, but what's missing? We have x to the 4th, we have x to the 3rd, we're missing an x squared. So we really have 0x squared right there. When we set up synthetic, we got to make sure to put a placeholder for the no x squareds right there. So in the box for this problem would be a 2, and our coefficients are 5, 2, 0, negative 20, and negative 6. So we'll put a 0 in if there is no or 0 of a certain variable there. Okay? And repeat it. Go ahead, see if you can do this one. Give you a little bit of time. If you need to pause, you can pause too. And then come back to it. So here's what we'll do. Bring down the 5. 5. Take 5 times 2, we get 10. Add straight down, we get 12. 12 times 2 is 24. Add straight down, we get 24. Multiply 24 times what's in the box, 2. We get 48. And then add straight down, negative 20 plus 48 is 28. Multiply right there, and we get 56. Add straight down, and that gives us 50. And if we plug in x equals 2, we get 50. So hopefully you got that correct. It's just a process that you go through. Hopefully it's a little easier than plugging in the actual number when you get to really big numbers. Okay, and then you'll see it's going to, synthetic substitution is going to go with some division stuff that we'll do here in a little bit. So that's synthetic substitution. Let's go ahead and move on to polynomial long division. Well, long division, polynomial long division is very similar to long division that you did back in elementary school. So if we're going to take 536 divided by 3, we'd create this 536 long division, division bar divided by 3. And if we do this correctly, we'd look at the 5, we'd look at the 3. How many times does 3 go into 5? It's 1. And then what did we do? We took 1 times 3, we got 3. And then what do we do with these numbers? We subtracted. 5 minus 3 is 2. And then we brought down the next one, which was a 3. How many times does 3 go into 23? That was 7. Take 7 times 3, we get 21. That goes below it. And then we subtract, which gives us 2. And bring down the 6. How many times does 3 go into 26? That would be 8. We bring that down. 8 times 3 is 24. And we repeat the process. We subtract, we get 2. Now this last number here, we have nothing else to bring down, so that was our remainder of 2. Well, another way to write this would have been 178 and 2 thirds. 178 and 2 thirds. So you can always write the remainder as a fraction over what we divided by. Next one, if we try to do that one, again, if you want to pause, I'll let you do that, you can. Otherwise, I'm going to go ahead and do it. 8,767 divided by 4. Let's just make sure we understand the process here. 4 goes into 8, 2. 2 times 4 was 8. We get 0. If we subtract, bring down the 7. 4 goes into 7 once. 4 times 1 is 4. Subtract, we get 3. Bring down the 6. We get 36. 4 goes into 36. 9 times 4 is 36. We subtract, we get 0. So we bring down the 7. 4 goes into 7 once. We get 4. Multiply, subtract, we get 3. That's our remainder. So it would be 2,191 and 3 fourths as our final answer. So that's long division with numbers. What we're going to do is long division with polynomials. So the problem we have here is x cubed plus x squared minus 2x plus 8 divided by x minus 1. We're going to set this up same way, division bar. Underneath the division bar goes the first one there, so x cubed plus x squared minus 2x plus 8, and we're going to divide by x minus 1. All right, just like with division with numbers, we're going to look at the first term, x cubed, and we're going to look at the first term out front, x. We want to see how many times is x going to x cubed, or what can we take and multiply x by to get x cubed? It's x squared, so we're going to write that x squared on top. And now we're going to take x squared times what's in front, x minus 1, or what we divided by. If we distribute there, we get x cubed minus x squared. That goes right underneath, x cubed minus x squared. Okay, so it's the same type of process as that long division with numbers. And then what did we do? We subtracted. So when we subtract, we need to make sure we change the signs of these. These cancel out. X squared plus x squared is 2x squared. And then what did we do? We bring down a number. It's very similar to long division with numbers. Okay, and we're going to repeat the process. Look at the first ones. X and 2x squared. X times what is 2x squared? It would be 2x, so that goes next. Now we take the 2x times x minus 1. I'm just showing you over here on the side what I'm doing for the bottom. 2x times x is 2x squared. 2x times negative 1 is negative 2x. So we go 2x squared minus 2x. Again, though, what do we do going down? We subtract, so we're going to subtract this, change the signs. These cancel out. Ooh, these also cancel out, so we get 0 here, and we just bring down the 8. Okay, well now look, what can we take x and multiply it by to get 8? Nothing. So 8 is our remainder. So our remainder is 8. That's that last number down there. So our answer is x squared plus 2x, and it's going to be just like that last one. We're going to put plus 8 over what we divided by, x minus 1, and that's our final answer. So long division of a polynomial is very, very similar to long division of a number. It's just a little more intense there. Okay? I'll pause for a little bit here. Let you get that written down if you didn't. And let's do another one. Okay, 3x cubed minus 7x squared minus 3x plus 8 divided by 3x plus 2. The key here with long division, anytime you have a coefficient in front of the x that you're divided by, so like 3x, we have to use long division. So here we go, 3x cubed minus 7x squared minus 3x plus 8 divided by 3x plus 2. All right, let's roll with this. Let's look at the first terms, 3x cubed and 3x. 3x times what is 3x cubed? That's x squared. So we're going to take x squared times what's in front, 3x plus 2. We're just repeating the process. And we get 3x cubed plus 2x squared. So that goes underneath. 3x cubed plus 2x squared. What do we do with those? We subtract. So change the signs. These cancel out. Negative 7x squared minus 2x squared is negative 9x squared. Bring down the negative 3x. All right, let's look at the first terms. Negative 9x squared and 3x. 3x times what is negative 9x squared? That would be negative 3x. So we're going to take negative 3x times 3x plus 2. That gives us negative 9x squared minus 6x. So negative 9x squared minus 6x goes underneath. Always, as you see, those first terms there should be the same. We're going to subtract, so we got to change the signs. Minus and minus is really plus. These cancel out. We get 3x right here. Bring down the 8. Look at the first terms. 3x and 3x. 3x times 1 is 3x. So now we take the 1 times 3x plus 2. That just gives us 3x plus 2. So underneath, we write 3x plus 2. What are we going to do? We're going to subtract. And these cancel out. We get 6. 6 is our remainder. So our final answer is x squared minus 3x plus 1 plus 6 over 3x plus 2. That is long division for polynomials. Polynomial long division. It's kind of just following through and copying down and following those steps. Okay? All right. Here is another problem. 3x cubed minus 2x squared plus 2x minus 5 by x plus 1. Let's try long division again. You can go ahead and get started on that. I'll try to go a little slower here. Or we could even pause if you want to pause and try it on your own and then double check with me. All right, 3x cubed and x plus 1. That's going to be x times 3x squared, so I'll put that right above there. 3x squared times x plus 1. I always just write this to the sides because it helps me out. I get 3x cubed plus 3x squared. So underneath here I go 3x cubed plus 3x squared. What do I have to do with those though? I need to subtract. These cancel out. I get negative 5x squared. Bring down the 2x plus 2x right there. All right, look at those first terms, x and negative 5x squared. So I'm going to multiply by a negative 5x. So I get negative 5x times x plus 1 over here. Take it times the front number. We get negative 5x squared plus negative 5x. Write that underneath negative 5x squared plus negative 5x. But again, we need to change the signs, so we're going to add, subtract. Minus a minus is really plus. These cancel out. We're left with 7x. Bring down the negative 5. Look at those first terms. X times what is 7x? It's 7. So we get 7x plus 7 right there. What are we going to do though? We're going to subtract. We're going to subtract, so these cancel out. We get negative 12, so our remainder is negative 12. Here we go. Final answer, 3x squared minus 5x plus 7 plus negative 12 over x plus 1. Final answer right there. Now, that might be a good time now to pause. Make sure everyone's on the same page. If you have questions, ask each other. Be respectful. Help each other out right now before we move on. That's our last long division problem. Okay, let's move on right now. So what I'm going to do is I'm going to take this answer and I'm going to copy it. And we're going to look at this problem, but this time we're going to do it using synthetic division. So I'm going to paste my answer right down here. Okay, so you have that answer. It's on your last slide. You don't need to paste it or rewrite it, but it's right there. Let's use this using synthetic division. Okay, synthetic division is just like synthetic substitution, which we did a little bit ago. The only difference is, notice here, we're dividing by x plus 1. The key is that it has to be just an x in order to use synthetic division. What we're going to put in the box, just like for synthetic substitution, is the opposite number. So when we're using division, we use the opposite number. If it's x plus 1, we're going to use a minus 1. Okay, synthetic division, use a minus 1. And then let's go ahead and put the coefficients down, 3, negative 2, 2, and negative 5. Now this is just a synthetic substitution type problem. We're going to use the same process. Bring down the 3. 3 times negative 1 is negative 3. Once you get the hang of this, it goes pretty fast. Negative 2 plus negative 3 is negative 5. Negative 5 times negative 1 is 5. 5 plus 2 is 7. 7 times negative 1 is negative 7. Negative 5 plus negative 7 is negative 12. Okay, now if you look at those, can you see any connection between what we just found and the answer to long division? If you're saying something about the coefficients, you are exactly right. What it does is it finds the coefficients for you in the answer. And then the number in the box is the remainder. Pretty sweet. So how do we write this? We write it with 3, and then we always go, see how this was 3x cubed and this was x? Well, what's 3x cubed divided by x? It's 3x squared. So see how it's one less degree? Well, that's where we'd start. So we always start with one less degree than our original. So if our original was 3x cubed, we're going to go 3x squared. And then we just work our way down from standard form. Minus 5x plus 7 plus negative 12 over x plus 1. And there is our answer. Same answer as we got before. So we can use synthetic division as well. Let's do another problem by synthetic division. There's the steps if you need to actually look at them and see what's going on. Again, synthetic division, the key is you got to divide by x minus k. There has to be just an x there. So let's do this problem. Negative x cubed plus 4x squared plus 9 by x minus 3. What number goes in the box? A positive 3. When you're using division, always use the opposite. All right, then what's missing here? We have negative 1, we have 4, but we don't have any x's. Notice we have 0 x's right there. So we're going to put a 0 in. This is synthetic division, just like synthetic substitution. Let's do it. Here we go. Negative 1. Negative 1 times 3 is 3. 4 plus 3 is 7. 7 times 3 is 21. Add straight down. 21 times 3 is 63. 63 plus 9 is 72. Oh boy, here we go. Let's figure out what the final answer is there then. All right, so the original was x to the third power. So we're going to write negative x to the second power. Negative because of the negative 1. Plus 7x plus 21 plus 72 over, what do we divide by? X minus 3. That goes right here as the final. So there is your final answer. That is synthetic division. Synthetic division. Synthetic division, use the opposite. Opposite, opposite, opposite. Okay? All right. Here's another synthetic division problem. Why can we use synthetic division on this one? Because it's just 1x right there. Here we go. Put a 3 in the box. 2, negative 5, negative 24, and 63. Let's see what we get here. Let's do this problem. If you want to pause, do it on your own, that's fine. Here we go. 2. 2 times 3 is 6. 1. 1 times 3 is 3. Negative 21. Negative 21 times 3 is negative 63. And we get 0? If we get 0, that means the remainder is 0. So our answer here would be 2x squared plus x minus 21. Now notice with the remainder of 0, what's that mean when you have a remainder of 0? Well, if I took like 56 and divided it by 7, I would get 8. Remainder 0. What's that mean about 8 and 7? That means 8 and 7 are what we call factors of 56. Well, same idea here. If we divide by x minus 3, that means x and get 0 as a remainder. X minus 3 is a factor. So really what that means is we could take x minus 3 times 2x squared plus x minus 2, and we'd equal out to our original problem. 2x cubed minus 5x squared minus 24x plus 63. So this factors, so x minus 3 is a factor since the remainder is 0. That's called the remainder theorem. All right? The type of problems you'll get with that is you'll say, okay, x to the fourth plus 2x cubed minus 8x minus 16 has a factor of x plus 2. Find the other factors. So we just use synthetic with this. Since it's x plus 2, we do negative 2. Here we take the coefficients from here. 1, 2. Oh, look. There's no x squareds. 0, negative 8, and negative 16. and we'd use synthetic division. Hopefully you're getting a little hang of this. Bring down the 1. 1 times negative 2 is negative 2. That's 0. 0 times negative 2 is 0. 0 plus 0 is 0. 0 times negative 2 is 0. Negative 8 plus 0 is negative 8. Negative 8 times negative 2 is positive 16. We get 0, and that makes sense because it is a factor, so the remainder is 0. Okay? So what are we left with right here? We're left with x cubed minus 8. That's our other factor. Now it says find the other factors. Well, can we factor? Well, then you want to go one step farther if possible. Can we factor x cubed minus 8? Yeah, that's x cubed minus 2 cubed. That's just a difference of perfect cubes. Hopefully remember that formula. X minus 2, x squared, plus 2x, plus 2 squared, which is 4. So our other factors would be these two right here. So when you get a problem like this, use synthetic with what it tells you to divide by. You should get a remainder of 0. Take your answer, whatever it is, from synthetic division and factor it more if possible. And that is synthetic division with a factor. Okay, remainder theorem 0. All right, that is it for today. So the rest of the time you're going to have to work on this assignment, page 355, numbers 9 through 25 odd, and then page 315, 12 through 16, 20 through 21, and 29. Use the rest of the time wisely, make sure you're working, and have an awesome, awesome rest of your Monday.